Hey, Mr. Winter, how often do you make chemistry jokes? Periodically. Hey. So today we're going to be looking at, of course, the periodic table, just to name a few important vocabulary words and the concepts that you're going to get when we're looking at the periodic table. So let's go ahead and get started here. Here's a generic version of your periodic table. You'll probably become very comfortable with this device throughout this year. A couple things that I want to point out. First off, remember groups and families are the columns. Groups and families are going to be the things that go up and down. So for example, right here, we have the halogen family. Over here, the purple, we have the alkali metals, they're a family. And then here we have the alkaline earth metals. These are all examples of families or groups, and elements that are in the same family share similar chemical and physical properties. Now, I do want to point out that we do call elements that are in the same row, so left and right, periods, but there's nothing much notable about that. Now, Dmitry Mendeleev is definitely the founder of the periodic table. Now, the reason I do air quotes is because people were trying to categorize elements for a long time. But Mendeleev is probably one of the most interesting because he was able to predict the existence of elements prior to their discovery based on patterns and other recognitions of those of the things of the elements that we had currently discovered. So once again, not the first person to try to organize the elements, but definitely the most successful because he was able to recognize patterns between elements. So really quickly, once again, he was the first person to recognize that some elements may not have been discovered yet. One of those being germanium, which is the element under silicone. And interestingly enough, he called that eka silicone. So eka meaning one beyond. Aluminum, eka aluminum was another one, otherwise known as gallium. So periodic law says this, the properties of the elements repeat periodically based on their atomic numbers. And periodically means repetition or order. So as far as what you should take away from this is that elements in the same group have similar chemical properties. Carbon, silicon, germanium, and tin have similar chemical properties. Nitrogen, phosphorus, arsenic, and antimony have similar chemical properties. And all I did there was just list elements that were in the same group or family. Now, the periodic table is broken up in a very specific way. Basically, we have on the left-hand side of the red section here, the metals, and on the right-hand side, we have the nonmetals. Now, hydrogen is over up here on the left-hand side. Hydrogen is the only element on the left-hand side that is a non-metal. It's kind of a lone wolf. It's out there all on its own. And what separates the periodic table is a list of 5 to 7 elements, depending on which one you look at, of the metalloids. Now, metalloids are here on the staircase, and they share properties of both metals and nonmetals. So let's go ahead and start with metals, identifying some of the most key, important, and features of the elements that exist on like 75% of the periodic table. So once again, metals are to the left of the metalloids. Metals absolutely can conduct electricity and heat. Metals are also malleable, ductile, and lustrous. Malleable refers to the ability for these substances to be hammered into sheets. Ductile refers to the ability for these substances, metals, to be pulled into wires. And lustrous refers to their shininess. Nonmetals are pretty much the opposite. Not completely, but there's a good handful of opposites. So for example, nonmetals are to the right of the metalloids. And of course, we include hydrogen here. Nonmetals are generally insulating. They are not very good at conducting heat or electricity. They're also often gases at room temperature. But the few that are solid, for example, sulfur or phosphorus, they are often brittle, chalky, and matte in color. They don't have a shine associated with them. And last but not least, once again, they do not conduct electricity and they are good insulators. Now, last but not least, I included one of my favorite shows down at the bottom here, Silicon Valley, but it is also one of the elements in the metalloid grouping on the periodic table. These are going to be elements that are in direct contact with the staircase, meaning that they are right, they share a sign with the dark line that's usually illustrated on your periodic table. And these elements are semiconductors and are often used within circuitry, like silicon or boron. And they share other properties that are similar both with the metal section and the non-metal. At the end of the day, really just recognizing where the metalloids at, and that the metalloids separate the metals from the non-metals is probably going to be the most important piece for you guys in AP chemistry. All right, thank you so much. And as always, remember you have a graphical organizer that follows along with this. If you guys have any questions, feel free to email me. Thanks a lot.